let's take a look at dividing with fractions. Now, we're going to stumble across some variables within that too, so you have to watch out for that. But first I want to discuss an idea called reciprocals. Let's say we have 4/5, and I asked you for the reciprocal of that. It's going to be 5/4. We need that idea in order to divide with fractions. Let's suppose that we have over here two fractions represented by a over b and c over d. In order to work this out, what we need to do is turn this into a multiplication problem. And we can do this by taking the reciprocal of that second fraction there, c over d, make it d over c. Then we can multiply through by our numerator and our denominators. Let's take an example. 2/3 divided by 1/5. The reciprocal of 1/5 is 5/1. Now we have a multiplication problem, and we can just multiply the numerators together and the denominators together. So we'll use that idea here. Now here's one that involves some variables. 2/3x divided by 4y over 3. So let's take the reciprocal pointed out by Dirac here of 4y over 3. And the reciprocal of it is 3/4y. Now we can also look to see if we can cancel. So we can cancel a 3 into a 3, and we can cancel a 2 into that 4. And 2 into 2 is just 1, and 2 into 4 is just 2. Multiply across, and we'll get 1/2xy. So we're learning to use fractions that involve variables. Now, 9a. Dirac, I think, is going to point this out to us. Can be thought of as 9a over 1. And if we take the reciprocal of it, we'll have 1/9a. So let's look and see whether or not we can do some canceling. 3 goes into 3 one time. 3 goes into 9 3 times. Multiply across. Now a times a is a squared. You add the exponents. So what's this? Looks like we're getting some kind of a delivery of some sort. Oh, it looks like our next problem. Okay, so 3b squared divided by b over 7. Now we have to look at that b over 7, take the reciprocal of that, and that will give us 7/b. And now we have a multiplication problem. Let's see if we can do some canceling here. I think we can. 7 into 7 goes 1 time. 7 into 14 goes 2 times. b goes into b 1 time. b goes into b squared b times. Let's see. Is that it? Okay, I think that's it. 3b over 2 is our answer. All right, let's see what our next problem is. It's going to be a special delivery too. So here's our truck backing up. Let's see what kind of problem it dumps on us. All right, 2x cubed over 15 divided by 4x over 21. Take the second fraction, turn it upside down there. Now let's take and do some canceling. Let's see what we can do. 2 into 2 goes 1 time. 2 into 4 goes 2 times. Now 3 will go into a 15 5 times, and 3 will go into 21 7 times. And then we can take an x into x cubed, and that's x squared, and x into x is just 1. Now, let's see, I think we're done here. Now, let's multiply across, and we get 7x squared over 10. So I hope we're catching on to this pattern here. We're not getting another delivery. No, we're not getting another delivery. Well, that looks like some of our friends that help us out, Newton and Hilbert. Oh, here's John Bernoulli. Wait a minute, they're taking our truck away. Does this mean that we have no more problems? I don't know. I thought there was one more problem here in this lesson. Oh, there it is. Okay. So let's take that second fraction, turn it upside down, the reciprocal of it there, and see what it looks like. So we got 9 over 48a bx. All right, we can cancel a 24 into 24, and 24 will go into 48 2 times. Then we can cancel 3 into 3 one time, and 3 into 9 3 times. Let's see what else we got. Oh, a will go into a square 8 times, a and a 1 time, and the b's cancel out. Okay, are we finished now? It looks like we are. Multiply across numerator and denominators, and we get 3a over 2x. Thank you.